We have a label now, and we should just have a read of what we see in there. We see this big 300 milligrams per 2 mils, so that's the concentration of the drug. But on the just below that, we see 150 milligrams per mil, which is also the concentration. But they are exactly the same, they are equivalent, except that the one that says 150 milligrams per mil, and we should remember this is per 1 mil, the invisible one, that is just a simplified concentration, and probably the one we should use, because we don't want to have bigger numbers in our calculation, because we want to be able to estimate it in our heads as well. So we could say it's 150 milligrams per mil, meaning per 1 mil. That's the concentration. So this is our have, the two quantities connected as a ratio. Now we need to find our want, which is what the patient will need to receive. In the question it says what volume of the drug will you administer for each dose. So it's not really telling us what the patient needs, but if we look at the chart, we see it really clearly here. 240 milligrams, that's what the drug dose and directions say. So this is our want. The patient will need that every 6 hours. So we start drawing our box, and we always enter our have in the first place, the two quantities that are connected, 150 milligrams, and write the unit inside the box, per 1 mil. So the have is entered. Now all we need to do is find a place for the want. Because the want is in milligrams, we must match it with the milligrams on the top. If the want was in milliliters, we would write it on the bottom. Now they are matching, and we can do some mental calc here, just wondering what happens, or what happened to the 150. If it goes up to 240, it means we multiply the 150 by a number. Could we have doubled it? 150 doubled would be 300. So no, we didn't, because 240 is less than 300. So what have we done here? We multiplied 150 by a number smaller than 2, 1 point something. So this is what's going to happen to the 1 mil as well. We are not doubling it, so it will be less than double of 1 mil, which would be 2 mils. This calculation we're doing in our heads is just to give us the safety as we use our calculator, and we know we are expecting an answer that is less than 2, not less than 20 or 200, less than 2. We just know the size of our answer. So how do we proceed here? We have to simply look for the main diagonal, which is always the one that has the 2 elements, and we're going to multiply that 1 mil by 240, and then divide by the third number, which in this case is 150. 1 times 240 is 240, divided by 150. We could even cancel those zeros, because we are dividing top and bottom of the fraction by 10, and then we can simply say how many 15s go into 24. Not 2, because 2 15s would be 30. So we have to say this is less than 2. We go to the calculator, and we enter 24 divided by 15, or 240 divided by 150, and we get 1.6. In the box, we see that this position here, where we need our answer, must match that 1 mil. So our answer should come out in mils or milliliters. 1.6 mils is what we need for each dose for this patient.